Alright, so we've talked about finding limits. We've talked about what a limit is and the different ways to find it. We talked about there being numerical, graphical, and analytical. And we already talked about how to do the numerical approach. Now let's talk about the graphical approach. The graphical approach literally just has us looking at the graph and seeing what the limit appears to be, or what the intended height of the function appears to be. So ideas here. So we got some basic, a little review of some notation that we've already talked about. And then we have this question here. And it says, for the function f graph below, find, and we're going to find all these limits. So let's just take a look at this first one. It's asking for the limit as x approaches 3, and then that little negative sign, remember, means from the left. So here's x is 3. I'll write it in. And as we come from the left, we can see, obviously, if this was, we can mark these so that we can see a little bit clearer. This is 1, negative 2. We can clearly see that the limit, or the height of this function as we approach x is 3 from the left, is just negative 1. So we're going to say that equals negative 1. What about item B? Well, this is just asking the same kind of idea. What's the limit of f of x as x approaches 3? But now with the plus sign, it's saying from the right. So now we're going to come this way on the function. And now the height appears to be positive 3. So 3. That's all there is to it. Pretty simple idea. So then what is the limit? What's the general limit then as x approaches 3? Meaning, remember, the general limit can only exist if the limit is the same from the left and from the right. And here it is not, and so we would just say that that does not exist. The limit does not exist because it's not the same. Alright, now this is not asking about the limit, this is just asking about the actual value of the function. So what is the function height at f equals 3? So if we go to the function, we can see it's only defined right here, this little dot, which means it's a height of 1. So that's just positive 1. And what is the limit of f of x as x approaches negative infinity? Well, assuming that this line keeps going, then it's going to stay at negative 1 as it gets closer and closer to negative infinity. So we're going to say negative 1. And what is the height as we go this way to the right, to positive infinity? Well, again, assuming that it stays that way, it would be 3. And so there, we've analyzed this function and all of these limits graphically. Let's go to the next page. Okay, so here's another example. Got an interesting absolute value function, but it has a little kind of what we call a little discontinuity here. And let's just kind of play with it. And again, if you think you know how to do this, I would just pause the video and do it on your own, and then kind of fast forward and check your work. But let's just kind of go over it real quick. Again, we're going to approach negative 2 from the left, so this appears to be negative 2 here. And this is negative 1, negative 2, 1, 2, and 3. So as we approach negative 2 from the left, we can see that it's coming down, and it looks like the limit is approaching 0. And then it's also asking for the limit as x approaches negative 2, but now from the right, same idea. It's going to the same height, so it's also approaching 0. Well, now we see we have the same limit from the left and the right. Therefore, the general limit is 0. And then here it's just asking for the actual value of the function at f equals negative 2. Notice the hole in the graph here. So 0 is not the actual value. The value is where we have a filled-in hole. So that's positive 2. And now this is saying, what's the limit as x approaches negative infinity? Well, it doesn't look like it's approaching any number, but we can tell that it's going up and up and up. I'm just going to put arrows there. If it's going up and up and up, then that just means it's getting closer and closer to positive infinity. And actually, the same thing's true as we approach positive infinity along the x-axis. This thing's just going up and up and up towards, again, positive infinity. So that's really all there is to it. I'll see you guys on the next video.